Hello everyone, in this video I'm going to discuss the example for limits. Kindly refers to the question, evaluate the situation given. Here we have limit when x approaching infinity for the function given. So kindly substitute the situation. So if we substitute the situation, and we will obtain infinity over the infinity, where we have the indeterminate form. So the strategy would be divide the highest power of the denominator. So kindly refers to the question, we have the denominator, we have the x. So my suggestion would be factor out the x. Limit when x approaching infinity. For the situation given, so here we have square root. If we factor out the x square, then we will have 1 plus with the 4 over x square. Then minus the 2 over the x. Rewrite the situation again. So limit when x approaching infinity, for the situation, square root of x square, square root of, we have 1 plus with 4 over x square minus the 2 over the x. Rewrite the situation again. Do remember, factor out the x. So in here, we have the situation, square root of x square. For the situation approaching infinity, so we can say that one will be the x. So factor out the x, then here we have square root of 1 plus 4 over x square. Minus, we have 2 over x. Over x bracket, we have the 1. So kindly simplify the situation. Limit when x approaching infinity, we have the square root 1 plus 4 over x square minus 2 over x over the 1. Next is to substitute the infinity. Then we will have the situation in here 0. Here also 0. So we have the situation y approaching the 1. Next, kindly refers to b. Limit when x approaching 1 over 2 from the left. For the function, we have the modulus 2x minus 1 over the 2x minus 1. Before we begin, let's focus on the modulus of 2x minus 1. Kindly define the situation, we have 2x minus 1, 2x minus 1 greater than equals to 0. Negative bracket 2x minus 1, we have 2x minus 1 less than 0. So simplify the situation. We have the modulus 2x minus 1, then we will have 2x minus 1, negative bracket 2x minus 1. For the domain, we have x greater equals to 1 over 2, x less than 1 over 2. So here we have the definition. Since this is a piecewise function, kindly illustrate the situation in the real number line, where we have x greater equals to 1 over 2, we have the function 2x minus 1. Next, we have the situation, negative bracket 2x minus 1. So kindly focus on the situation given. If we substitute the situation, then we will have 2 multiplied with 1 over 2. Then we have 1 minus 1, which is equals to 0 over the 0. Where we have the indeterminate form. So the suggested strategy would be conjugate, factorize, and also the long division. So for this case, I prefer the factorization. So rewrite the situation. So limit when x approaching 1 over 2 from the left. So for the modulus one, we have from the left. So we will have negative bracket 2x minus 1 over 2x minus 1. Notice that we have the common terms, so we can simplify. So when x approaching 1 over 2 from the left, after we simplify, we have the negative 1. So the value of y will be approaching negative 1 when the x approaching 1 over 2 from the left for the function fx. Next, kindly refers to c. Limit when x approaching 4 from the right. We have the function 1 over square root of x minus 1 over 2 over x minus 4. So kindly substitute the situation, and we will have the situation 0 over the 0. So where we have the indeterminate form, the suggested strategy will be multiply by the conjugate, factorize the situation, or long division. So for this case, my suggestion would be multiply by the conjugate. So before we multiply by the conjugate, let us equal the denominator. So limit when x approaching 4 from the right. So here, if we equate the denominator, we will have 2 minus the third x over, we have the 2 multiplied with the third x over x minus 4. Rewrite the situation. So limit when x approaching 4 from the right, we have 2 minus third x for the numerator. And for the denominator, we will have 2 sec x multiplied with x minus 4 for the denominator. Continue. Multiply by the conjugate, we have 2 plus with the set x, 2 plus with the set x. So do remember, only expand for one part. So limit when x approaching 4 from the right. So here we will have 4 minus, we have the situation x, over, we have 2 set x, multiply with x minus 4, multiply with 2 plus with the set x. Rewrite the situation. So limit when x approaching 4 from the right. Factor out the negative and we will have x minus 4, over, we have 2 set x, multiply with x minus 4, 2 plus with the set x. Simplify. So x approaching 4 from the right, we have negative 1, over, we have 2 set x, multiply with 2 plus with the set x. Then, if we substitute the situation, and we will have the situation given in here. If we substitute 4, we have 2. So negative 1 over 2, multiply with the 2, bracket 2 plus with the 2. So limit when x approaching 4 from the right. For the function 1 over set x minus 1 over 2 over, we have x minus 4. So the value of y will be approaching negative 1 over 16. Hello everyone, in this video I'm going to discuss the example for differentiation. Kindly refers to the question, differentiate the fx where we have the situation, let's say y is equals to x squared multiplied with the exponent x. Find the value of x when the f prime x is equals to 0. So first of all, differentiate the situation with respect to x. So in here we are making use of the product rule. So where we have y prime equals to v u prime plus u v prime. So let's say here we have the u and then the v. So differentiate the situation, we have the dy dx equals to, we have the v. Differentiate the u. So here we have 2x plus, copy the u and then differentiate the v. So here we have the dy dx. So given the situation, dy dx is equals to 0. So kindly substitute, we have 2x exponent x plus the x squared exponent x equals to 0. Exponent x bracket, we have 2x plus the x squared equals to 0. So as we can see, exponent x equals to 0, continue, x is equals to 0, and then bracket we have 2 plus the x is equals to 0. So for this case, x is equals to ln 0, where we have no solution. Another one, x is equals to 0. Another one, we have x is equals to negative 2. So that is the value of x when f prime x is equals to 0. Next, find the dy dx when y is equals to set x over the cos x. So for this case, we have the quotient rule. Let's say here we have the u, here we have the v. So for the quotient rule, we have the formula v u prime minus u v prime over the v squared. So let's begin. We have the dy dx, where we have the v, which is the cos x, and then differentiate the u, where we have 1 over 2 set x bracket, we have the 1, minus, we have the u, differentiate the v, so we have negative sine x multiplied with the 1, over, we have the cos x bracket square. Simplify the situation, we have the cos x over the 2 set x minus become plus, we have the set x sine x over the cos square x. Rewrite the situation, or we can say equal the denominator for the numerator part. So we have cos x plus, if we multiply with the 2 set x, and then sine x, over, we have the 2 set x cos square x. Rewrite the situation. So cos x plus with the 2x sine x, over, we have the 2 set x cos square x. So that is the dy dx. Hello everyone, in this video I'm going to discuss the example for application of differentiation, where we have the rate of change. Kindly refers to the question, air is pumped into a spherical balloon at the rate where we have 250 cm cubed per second. So kindly illustrate the situation given. So in here, let's say we have a spherical balloon. Write the formula. We have the area. We have the volume. So if it refers to the question, they said we have the rate 250 cm cube per second when the radius of the balloon is 15 cm. So we can illustrate R is equals to 15 cm. So Kali refers to the question A, the rate at which the radius is increasing. So the first step is to extract the info, including the situation given. We have dr dt, which is the question mark. Second step, where we have to write the chain rule based on the question given, dr dt, which is equals to dv dt, multiply with, we have the dr dv. So based on the situation given, we have v in terms of r. So step number 3 refers to the formula. We have the volume, v equals to 4 over 3 multiplied with pi r cube. So we have v in terms of r, dv dr, then we have 4 pi r squared. So Kali substitute into the second step. So here we have step number 4, dr dt equals to, we have the dv dt, where we have 250 multiplied with 1 over 4 pi r squared. Substitute r equals to 15. So if we substitute, we will have 250 over 4 pi multiplied with the 15 squared. So the dr dt would be 5 over 18 pi. We have the cm, and then we have the s negative 1. So that will be the answer for the question A. Next, Kali refers to the question B, the rate at which its surface is increasing. So question focus about dA dt. So second step, write the chain rule. We have the dA dt equals to, so if it refers to the situation, information given, we have the dV dt, which is equals to 250, and then multiply, we have the situation, we have the dA dr. If it refers to the equation on the left hand side, formula, area. So if it refers to the chain rule, we notice that we already have the dA, but we need to eliminate the dV and also the dr. So here we have the dr, and then here we have the dV in order to have dA dt. So Kali rewrite the situation. We have the dA dt equals to, in here we have the dV dt multiplied with the dr dV, and then multiply with the dA dr. And kindly refers to this part. Notice that we already get the dr dt based on the question A. So we can just straightforward substitute. Next, refers to the situation A in terms of r. dA dr, where we have 8 pi r. So kindly substitute. In order to find the dA dt, so in here we have the situation 5 over 18 pi. Multiply with, we have, so refers to the situation, we have dA dr, so no need to flip. Then we can straightforward 8 pi r bracket when the r is equals to 15. So kindly simplify the situation, and we have 5 multiplied with the 8 and then pi and then also the r, where we have the 15 over, we have 18 pi. So if we simplify, we have the dA dt, which is equals to 100 over the 3 cm squared because of area, and then s negative 1 because over the dt, where we have per second. Hello everyone, in this video I'm going to discuss an example for complex number. Kali refers to the question, the complex number z satisfy the equation where we have the 4z minus the 3 conjugate of z equals to 1 minus 18i over 2 minus I, where the z or the conjugate of z denoted as the complex conjugate of z. Find the z in terms of x plus yi, where the x and y are real number. So z as a x plus with the yi. So kindly substitute the situation. We have the 4z minus the 3 conjugate of z equals to 1 minus 18i over 2 minus I. So focus on the right hand side. We have to multiply by the conjugate, so that the situation for the denominator will become the real number instead of complex number. So 4z minus 3z bar, where we have 2 plus with the I minus the 36i, and then plus with the 18 over, we have the 4 plus with the 1. So if we simplify, then we will have 20 minus 35 over the 5. So focus on the left hand side. 4 bracket, we have x plus theta y I minus 3 z bar, where we have x minus y I. So if we expand, we have 4x minus the 3x plus 4yi plus with the 3yi equals to, we have 4 minus 7i. If we simplify on the right hand side, next we have the real part and also the imaginary part. Kindly compare the parts. 4x minus 3x, where we have x, which is equals to 4. 4y plus with the 3y, where we have the 7y, which is equals to negative 7, y will be equals to negative 1. The x is equals to 4 and the y is equals to negative 1. So the z will be equals to, we have the situation 4 minus I. Whereas for the z bar, we have 4 plus with the I. Hello everyone, in this video I'm going to discuss an example for equation and also the absolute value inequalities. So kindly refers to the question A, solve the equation given. So my suggestion will be simplify the situation in the base 2. So for the 4, we can simplify as 2 to the power of 2 bracket, then we have the 2x. Multiply, we have 2 to the power of 3 bracket, we have 3x. Over, for the 32, we have 2 to the power of 5 bracket, and then we have 1 minus x equals to 1. We may cross multiply the situation. So in here we have 2 to the power of 4x multiply with 2 to the power of 9x, which is equals to 2 to the power of 5 minus 5x. Focus on the left hand side. We can make use of the rules of indices. 2 to the power of 13x is equals to 2 to the power of 5 minus 5x. Since we have the same base, we can compare the index, where we have 13x equals to 5 minus 5x. So 18x is equals to 5. X is equals to 5 over 18. Kali refers to B. Without squaring the inequalities, solve the situation given. So kindly focus on the situation. We have the n case. Based on the definition, we have the n case. So here we have negative 1, and then we have 4x plus with the 3 over x plus with the 1 less than 1. So based on the definition, we have the n case. 4x plus with the 3 over x plus with the 1. So here we have less than 1. Here we have greater than negative 1. Kindly split the situation. So here we have 4x plus with the 3 over, we have x plus with the 6 less than 1. N case, we have 4x plus with the 3 over x plus with the 6 greater than negative 1. Focus on the left hand side. We have the inequalities. So we have the 4x plus with the 3 minus multiply with the denominator, or we can say equal the denominator. So we will have this form. So notice that we have 4x minus x, we have 3x, and then 3 minus the 6, we have negative 3 over x plus with the 6. So here we have the simplest form, or we can rewrite 3 bracket x minus 1 over x plus with the 6 less than 0. So determine the sign, we have the negative sign. Then x greater than 1, x greater than negative 6, because we assume always positive. Illustrate the situation in the real number line, we have negative 6 and also the 1. So here we have the negative, negative, negative. So here we have the positive, negative, and then the positive. The sign that we want would be the negative sign. So we have negative 6 until 1, where the negative 6 and 1 is not included. Next, focus on the right hand side. We have the 4x plus with the 3 plus bracket x plus with the 6. So rearrange at the same time, we equal the denominator. So here we have 5x and then plus with the 9 over x plus with the 6. So here we have the simplest form. Then next is to determine the sign. So x is greater than negative 9 over 5. X is greater than negative 6. Number line, we have negative 6, negative 9 over 5. So empty circle towards the right, empty circle towards the right, negative. So we have positive, negative, and positive. So in here we have the positive. Then we can have negative infinity until negative 6, where the negative 6 is not included, negative 9 over the 5 until infinity. Next is to combine them and then make use of the operation n. So real number line illustrate the number negative 6, followed by we have negative 9 over the 5 and also the 1. Focus on the left hand side, we have the negative 6 until the 1. Second part, blue in color, we have the negative 6 and then we have the negative 9 over the 5. So for the n case, we have to find the intersection between the two intervals, and here will be the answer. So the answer for the situation would be x such that we have x is greater than negative 9 over the 5 and less than the 1. So that would be the set solution. Next, refers to the question, hence obtain the solution if we have the modulus of 4x plus 3 over the x plus 6 is greater and equals to 1. So for this case, we have less than 1, so that would be the answer. For the another part, means that outside the green in color, so that will be the answer for this second part. So the answer would be x such that we have x less than negative 6. Included, not included, because x plus 6 is in the denominator, so x cannot be equals to negative 6. Or, continue, x is greater than negative 6, less than and equals to negative 9 over the 5. Or, we have the situation, x is greater and equals to 1. So that will be the answer for the second part, or the solution set for the situation greater and equals to 1. Hello everyone, in this video I'm going to discuss the example for function and graph. Kindly refers to the question, the function f is defined by the situation. So here we have the fx where we have 2x squared minus 8x plus with the 5. A. Express the function as a standard form and hence find the range. So what we have to do is to completing the square, factor out the 2. So here we have x squared minus 4x plus 5 over 2. Next, completing the square, we have 2 bracket x squared minus 4x minus become plus bracket negative 2. Why negative 2? Because of the negative 4x, we pick up the negative 4 and then over the 2. And then minus negative 2 bracket square plus with the 5 over 2. So continue, simplify, 2 bracket. So focus on this part, we have x minus the 2 bracket square. And then we have negative 4 plus with the 5 over 2. Negative 4 will be negative 8 over 2. So we will have negative 3 over the 2. Expand. So we have 2 bracket x minus 2 bracket square and then minus the 3. So that is the standard form for the fx. So refers to the situation, we have the minimum point where we have 2, negative 3. So that is the value for x and also for the y. So if it refers to the question, the domain for the f would be negative infinity until infinity. For this case, which is not one-to-one situation. If for the range, we have to refer to the minimum point. Since the graph is a positive graph, so the graph will be in a U shape, which is the minimum. So the lowest value would be the negative 3. So the range will be negative 3 until infinity, where the negative 3 is included. So that is the situation for the A. So if it refers to B, why? Explain why f does not have an inverse. So do you know why? Because for the domain. So for the question B, since the domain for the f is negative infinity until infinity, and it is not one-to-one function. If it's a not one-to-one function, then we can say f inverse does not exist. So that is the end of the story for the question B. Based on the second part, the function g is defined by the gx, where we have 2x squared minus the x plus with the 5. So if you notice that, actually the g and the f is the same. So never mind, we just pick up the situation. They ask you to find the domain, okay, where x is greater equals to K. So if it refers to the situation, C, find the smallest value of K for which the group have inverse. So when they said they got inverse, means that one-to-one function. So we have to refer to the minimum point. Okay, this is what we have, the minimum point. Just refers to the value of x. So for the case gx to be 1-to-1, the domain for the g will be equals to, start from the 2 until infinity. So if it refers to the situation, the value of k will be equals to 2. So that is the answer for k. Refers to D, for this value k, find an expression of the G inverse. So now we are going to find the G inverse. Let the y is equals to gx. G inverse of the y is equals to x. So let's begin. Y is equals to 2 bracket x minus 2 bracket square over minus the 3. So can we rearrange? We have x minus the 2 bracket square, which is equals to, we have y plus with the 3 over the 2. So x minus 2, which is equals to square root of y plus with the 3 over the 2. Why only positive? Because of the domain. They say start from 2 until infinity. So we ignore the negative part. So x is equals to square root of y plus with the 3 over the 2 plus with the 2. So G inverse of the x, where we have the square root of x plus with the 3 over the 2 plus with the 2. So that is the function for the G inverse. Kali refers to the E, sketch the graph of G and G inverse. So I would prefer refers to the quadratic graph instead of G inverse. So now we are going to sketch the graph. If it refers to the graph of the G, so here we have gx is equals to 2 bracket x minus 2 squared minus the 3. And we all know the minimum point is 2, negative 3. So step number 1, in order to sketch the graph for the gx, is the shape. Second step, we have to find the x and also the y-intercept. So based on the situation, 2 until infinity means that y-intercept does not exist for the moment. Never mind, we just focus on the x-axis, our x-intercept. So means that when y goes to 0. So Kali refers to the calculator. So if y equals to 0, so we have 2 bracket x minus 2 squared minus the 3. So rearrange, we have 3 over the 2, we have the square root, and then plus with the 2 equals to the x. So from here, we notice that we have the point 2 plus with the third 3 over 2, 0, would be the x-intercept. Next, we have the minimum point. So 2, negative 3. At the same time, we have the symmetrical axis. X is equals to 2. So let's sketch the graph. So focus on the situation. So in here we have the minimum point. Let's say here we have 1 and then 2. 1, 2 and 3. So here will be the minimum point. So 2, negative 3. So if we sketch the graph, do remember we have the y is equals to x. So for the graph, here we have the situation something like this. So here we have the gx. And the intersection would be 2 plus with the third 3 over 2 and then 0. Next is to find the G inverse. So in here, we have to flip the x and y. So we have negative 3, 1, 2, and negative 3. Here we have 1 and 2. So here will be the reflection for the minimum point. Then here we name it as negative 3 and then the 2. So for this case, we have 2 plus with the third 3 over 2, 0. So if we flip, here we will have the situation something like this. So here we have the G inverse. So the name would be 0, 2 plus third 3 over the 2. So that is the y-intercept. So that is the graph for the G and also the G inverse. Hello everyone, in this video I'm going to discuss the example for function and graph. Kali refers to the question. The function f and g are defined by the situation given, where we have f and also the domain x greater than negative 3 over 2, and the g, the domain with x greater equals to 0. Find the f inverse bracket, we have the number x 3 over 2. So my suggestion would be find the inverse first. So y is equals to fx. f inverse of y where we have x. So y is equals to 8x plus with the 5 over 2x plus with the 3. Cross multiply the situation. So we have 2x plus with the 3 multiplied with the y, and then we have x plus with the 5. Expand and then rearrange based on the terms. So we have 2xy plus with the 3y equals to 8x plus with the 5. So we have 2x minus 2xy minus the 8x is equals to 5 minus 3y. Factor out the x. So we have 2x minus the 8. We have 2y minus the 8 equals to 5 minus 3y. So x will be equals to 5 minus 3y over, we have the 2y minus the 8. So the f inverse of the x will be equals to 5 minus 3x over 2x minus the 8. So by refers to the calculator, f inverse of 3 over 2, if we substitute, we have 5 minus 3 bracket 3 over the 2 over, we have the 2, 3 over the 2 minus 8. So the f inverse for the value of x, 3 over 2, the value of y will be negative 1 over 10. Next, Kali refers to b. Shows that we have the fx. So here we have the fx, where we have 8x plus the 5 over 2x plus the 3. The question asks us to express the situation in this form. So for me, this would be the improper form. This one would be the proper fraction. So my suggestion is making use of the long division. So we have 8x plus the 5. We have the 2x plus 3 as a divisor. So multiply by the 4. So we have 8x plus the 12. So 5 minus the 12 and we have negative 7. So rewrite the situation, we have 4 minus 7 over 2x plus the 3. So we can compare, and A will be equals to 4, B will be equals to negative 7. Kali refers to C. Find the f rho g and also its range. So composite function f rho g. So meaning that we have the f bracket g. So x minus 3 over the 2. Kali substitute the g into the f. So we have 8 bracket x minus the 3 over the 2 plus with the 5 over 2 bracket x minus the 3 over 2 plus with the 3. Kali simplify. So we have 4x minus the 12 plus with the 5 over, we have x minus the 3 plus with the 3. So if it refers to the situation, so we have 4x minus the 7 over the x. So that is the f rho g. So continue. Based on this case, the domain for f rho g would be negative infinity until 0, union 0 until infinity. So in order to find its range, my suggestion would be let the h be the f rho g. So here we have 4x minus 7 over the x. Let the hx equals to y. X is equals to h inverse of y. So y is equals to 4x minus 7 over the x. So cross multiply, we have xy minus the 4x where we have negative 7. Factor out the x. So we have y minus the 4 equals to negative 7. X is equals to 7 over 4 minus the y. So the inverse, h inverse of x is equals to 7 over 4 minus the x. So the domain for the h inverse would be negative infinity until 4, union 4 until infinity. So automatically, we have the range for the f rho g. Hello everyone, in this video I'm going to discuss the example for limits and continuity. Kali refers to the example. Determine whether the function given fx is a continuous at x is equals to 4. So in here, notice that we have the modulus for the x minus 4. So Kali defined the situation, modulus x minus 4. So if we define, we have x minus 4, bracket, we have negative x minus 4. Then we have the domain x greater equals to 4, x less than 4. So kindly illustrate the situation in the real number line. So for the left hand side, we have x less than 4. So here we have negative x minus 4. For the right hand side, we have x minus 4. So if it's equals to 4, we have x minus 4 as well. Next, kindly focus on the question. Question mentioned about the continuity. So step number 1, F4. If it refers to the number line, we are moving towards the right hand side where we have to substitute the 4 into the x minus 4. Then we will have the situation. So x minus 4 minus the 2 over the x. So if we substitute, we will have negative 2 over the 4 and we can have negative 1 over 2. So if for the F4. Second step is to find the limit when x approaching 4 from the left, and we have another one, limit when x approaching 4 from the right. So kindly substitute the situation. So based on the situation given, 4 from the left. So we will have negative bracket x minus 4 minus the 2 over the x. So rewrite the situation, limit when x approaching 4 from the left. So 4 from the left, we will have negative x plus with the 4 minus with the 2 over the x. Limit when x approaching 4 from the left. So notice that we have negative x plus with the 2 over the x. So kindly substitute the situation. So if we substitute the negative 4 plus with the 2, so we will have negative 2 over the 4. So from here, we have the situation, limit when x approaching 4 from the left for the function fx, and we have the value of y approaching 1 over 2, negative 1 over 2. Next, focus on the right hand side. So here we have x minus the 4 minus the 2 over the x. So rewrite the situation, limit when x approaching 4 from the right. So notice that we have x minus the 6 over the x. So if we substitute the 4, and we will have negative 2 over the 4, and we will have limit when x approaching 4 from the right for the function fx, the value of y will be approaching negative 1 over 2. Notice that limit when x approaching 4 from the left for the function fx is equals to limit when x approaching 4 from the right for the function fx. So equal for both sides, and the limit when x approaching 4 for the function fx, the value of y approaching negative 1 over 2. So that is the second step. Third step, we have f4 equals to limit when x approaching 4 for the function fx. The value are the same. Then we can say that fx is continuous at x is equals to 4. Okay, next, kindly refers to b. Given the function fx, where we have 2x over the square root of x squared plus 2. By finding the limits at the appropriate value, obtain the horizontal and also the vertical asymptote, if they exist, and then hence sketch the graph for the function fx. So, step number 1, find the domain. If it refers to the situation in here, we notice that it is a real number. And then, focus on the bottom part, we have the x squared plus with the 2. So notice that x squared is a positive value plus with the 2. Very obvious. If we substitute any numbers, and we will also get a positive value. So based on the situation given, step number 1, the domain is negative infinity until infinity, or we can say a real number. Second step is to find the xy intercept. So focus on the x-intercept means that when y is equals to 0. So kindly substitute the situation, and we notice that x is also equals to 0. Continue. In order to find the y-intercept when x is equals to 0, and y will be equals to 0, so we have the coordinate 0, 0. So for the both x and y intercept. Next, number 3. Focus on the vertical asymptote. By referring to the domain, and we notice that there is no any asymptote, so we can say no vertical asymptote. Step number 4, we are going to focus on the horizontal asymptote. So limit when x approaching negative infinity. For another side, limit when x approaching positive infinity. So kindly substitute the situation. So here we have the 2x over the square root of x squared plus theta 2. So if we substitute, we will have a negative infinity over the infinity where we have the indeterminate form. So my idea is to factor out the x. So if it refers to the highest power of the denominator, we notice that we have the x squared and also the square root of the x squared. So limit when x approaching negative infinity, if we factor out the x, we have the 2 over, if we factor out the x squared, and notice that we have the square root of x squared, which is also equals to x. Square root, we have 1 plus with the 2 over the x squared. So based on the situation negative infinity, we can say that the square root of x squared will be the negative x. So limit when x approaching negative infinity, we have the x, so 2 over, we have the negative x, multiply with the square root, 1 plus 2 over x squared. And we can simplify, and if we substitute the situation, we will have negative 2 over the 1. So limit when x approaching negative infinity, for the situation fx, the value of y will be approaching negative 2. Next, continue. We have the right hand side, 2x over, we have the square root of x squared, multiply with 1 plus 2 over x squared. Since this is a positive infinity, so we can say that limit when x approaching positive infinity, we have the x, divide by, we have the positive x as well. So based on the situation, and we can say we have the value 2. So the horizontal asymptote, we have y is equals to negative 2, and also y is equals to 2. Next, we have to sketch the graph. Okay, so now focus on the graph. Number 1, we have the all real number. So means that there is no vertical asymptote. Number 2, we have the coordinate 0, 0. Number 3, no vertical asymptote. So next, we have y is equals to negative 2. So let's say here we have y is equals to negative 2. Another one we have y is equals to 2. So meaning that when x approaching negative infinity, we will approaching either above the negative 2 or below the negative 2. Same goes to the right hand side, above the 2 or less than the 2. By referring to the calculator, kindly key in this function and then calculate the value when x is equals to negative 50. And we notice that we have the value which is above the negative 2. Same goes to the right hand side. When we key in 50 as a x, then we will have the value less than 2. So the graph will be something like this. So that is the situation for these questions. Hello everyone, in this video I'm going to discuss the example for differentiation. So kindly refers to the question, given we have the ln bracket y squared plus 1, which is equals to x. Find the dy dx and also the second derivative in terms of y. So if it refers to the question, we are dealing with the dy dx. So kindly focus on the left hand side. If we differentiate the ln, so we will have 1 over y squared plus theta 1. Next, differentiate the internal function. So we will have 2y dy dx. If we differentiate the 1, we will have 0. Focus on the right hand side. If we differentiate x, and we will have 1. So kindly rearrange the situation. So we have the dy dx, which is equals to, we have the y squared plus theta 1 over the 2y. So that is the dy dx. Or we may rewrite the situation. We have y over the 2 plus with 1 over 2y. Next, focus on the second derivative. So we have the second derivative. If we differentiate this one, so we will have 1 over 2 bracket dy dx. Plus, focus on this part, and we will have 1 over 2 bracket negative 1 over y squared. Do remember, add on the dy dx. Next, continue. Focus on the dy dx. So we have to substitute the dy dx. So if we substitute the dy dx, we have the second derivative, which is equals to 1 over 2 bracket. We have the situation, which is y squared plus theta 1 over the 2y. Plus, we have 1 over 2 bracket negative 1 over y squared bracket. We have the y squared plus theta 1 over the 2y. Kindly rewrite the situation. So in here, we have the y squared plus with the 1 over the 4y. Minus, we have the situation y squared plus with the 1 over, we have the situation 4, and then continue, we have the y to the power of 3. So kindly equate the denominator. What we have to do is to multiply the y squared for this part. So rewrite the situation. The second derivative, where we will have y to the power 4 plus with the y squared, and then minus the y squared, and then minus the 1 over the 4y cubed. Finally, we have the second derivative, which is equals to y to the power 4 minus the 1 over 4y to the power of 3. So that is the first derivative and also the second derivative in terms of y. Next, focus on the b. Given the situation, we have x squared y equals to sine bracket, we have 2x squared plus with the pi. So let's focus on the situation, making use of the product rule. So here we have y bracket, we have 2x. Plus, we have the x squared, differentiate the y, and we will have dy dx. Which is equals to, if we differentiate the sine, and we will have the cos bracket, we have the 2x squared plus with the pi. Differentiate the internal function, and we will have the 4x. Kindly rewrite the situation. We have 2xy plus with the x squared. Then here we have the y prime. And then equals to, we have the 4x cos bracket, we have the 2x squared plus with the pi. So that will be our simplest form for the first part. Next, focus on the second derivative. So refers to this part, and we will have y bracket 2. Plus, we have the 2x. If we differentiate the y, and we will have the y prime. Continue. Plus, we have the y prime. Then if we differentiate, and we will have the 2x. Plus, we have the x squared. If we differentiate the y prime, and we will have y double prime, which is the second derivative. Continue. We have the cos bracket 2x squared plus with the pi. Differentiate the 4x, and we will have the 4. Plus, we have the 4x. If we differentiate the situation, and we will have the negative sine bracket 2x squared plus with the pi. Kindly differentiate the internal function, and we will have the 4x once again. Rewrite the situation. So in here we have the 2y, and then in here we can say 4x, and then we have the y prime. Continue. We have plus, we have the x squared, then we have the y double prime. Continue. Rewrite the situation. We have 4 cos bracket 2x squared plus with the pi, and then minus, we have the 16x squared multiply with the sine bracket 2x squared plus with the pi. So kindly refers to the question in here. So kindly check the situation. We already achieved the 4x dy dx. We have already achieved the x squared for the second derivative. Next, we already achieved this part, 4 multiplied with the cos bracket 2x squared plus with the pi. Kindly rearrange the situation. And we notice that actually the sine bracket 2x squared plus with the pi, which is equals to 2y plus with the 16x squared. Multiply with the situation here we have x squared y. Then plus we have the 4x, then y prime. Plus we have the x squared, then we have y double prime equals to 4 multiplied with the cos bracket 2x squared plus with the pi. So notice that we can factor out the situation 2y. So if we factor out the 2y bracket, we have the 1 plus with the 8x to the power 4. Plus we have the 4x multiply with the dy dx. And then continue. Plus we have the x squared, and then differentiate with the second derivative. And then equals to 4 cos bracket, we have the 2x squared plus with the pi. So we already shown the situation given. Hello everyone, in this video I'm going to discuss the example for the situation, which mixed with the chapter 9, the differentiation, and also the application of differentiation because of the stationary point. A curve is given by the parametric equation where we have the situation x is equals to a, which is the constant, multiply with the cos t, and then plus with the t sine t. Whereas we have the y, which is equals to a bracket, we have the sine t minus the t cos t. So where the t is in between 0 and also the pi, shows that we have the dy dx which is equals to tangent t. Continue, find the coordinate of the stationary point. So let's focus on this part. We have the dx dt. So differentiate the internal function. So where we have negative sine t bracket 1 plus we have the product rule. We have the sine t bracket 1 plus with the t, differentiate the sine and we will have the cos t and then multiply with the 1. So rewrite the situation. So we have the dx dt which is equals to a bracket. If you notice that here we will have 0. So we will have t cos t. Next, focus on the y. We have the dy dt. A bracket, differentiate the sign and we will have the cos t multiply with the 1 minus. Now we have the product rule. Bracket, cos t multiply with the 1 because we differentiate the t plus t, differentiate the cos and we have negative sine t bracket, we have the 1. So rewrite the situation. So dy dt which is equals to a bracket. Notice that cos t minus the cos t, so we will have 0. Continue, we have the t and then sine t. Next, find the dy dx. So dy dx which is equals to dy dt multiply with the dt dx. Kindly substitute. So here we have a bracket t sine t over, because we have to flip the situation, dt dx. So a bracket t cos t. If we simplify, dy dx would be sine over cos, which is the tangent t. So we already shown the situation given. Next, find the coordinate of the stationary point. So how to find the stationary point? Number 1, we have the dy dx which is equals to 0. So automatically, number 1, we can say tangent t which is equals to 0. Based on the situation, we have quadrant 1 and also the 3. Next, t is equals to 0 degree. So that is the basic angle. So the basic angle will be around here and also here. Continue, refers to the diagram. So here they mention that 0 until pi. So meaning that here will be the rotation. So where the pi and also the 0 are included. So automatically we can say the t which is equals to 0 degree and also the 180 degree. So t can be 0 radian and pi radian. Continue, we have to find the coordinate. So when the situation where we have the t which is equals to 0. So automatic x is equals to a bracket, we have the cos 0. So if it's a cos 0, where we have 1. And then if we have the t which is equals to 0, automatically here we have the 0. So automatic x will be equals to a. For the y, if the t is equals to 0, so here we will have a bracket, sine 0 we will have 0. And then if the t also 0, then we will have negative 0 as well. So the y will be equals to 0. So the coordinate of the stationary point will be a 0. If the situation t is equals to pi, automatically, so when x is equals to a bracket, notice that if we substitute pi into this part and also this part, and we will the negative 1. So x will be equals to negative a. Continue, for the y, so here we have a. If we substitute here, we have the pi and also this part, so automatically we will have the situation negative pi. So y will be equals to negative a pi. So the stationary point would be negative a pi. So both of these are stationary point. If you're new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.